Trevor asked this question, curious about what would happen if all lightning strikes in the world occurred in the same place at once. They say that lightning never strikes the same place twice, and that is not true. It's surprising that this statement still exists. One might think that people who believe in it would gradually leave society. Many wonder if it is possible to extract electrical energy from lightning. At first glance, this makes sense. Lightning is electricity, and lightning looks quite powerful. The problem is that a lightning strike occurs very quickly, and the total amount of energy it transmits is not that great. Moreover, achieving a lightning strike in the right place is quite difficult. A medium lightning strike can power a residential house for about 2 days. This means that even the Empire State Building, struck by lightning about 100 times a year, cannot power a home solely with lightning. Even in regions with high lightning activity, like Florida or the eastern part of Congo, the energy delivered to the Earth by sunlight exceeds the power received from lightning by 1,000,000 times. It's logical. After all, lightning is powered by solar energy. Extracting energy from lightning is like building a wind turbine that works on tornadoes. It's impractical, though it sounds pretty cool. In Trevor's scenario, all lightning strikes in one place, making energy production much more appealing. Let's assume all lightning strikes parallel to each other, one next to the other. The main channel of lightning, the one that actually conducts the current, is about 1 to 2 centimeters in diameter. If you gather about 1,000,000 individual discharges, it forms a beam about 6 meters in diameter, striking an area of land the size of the central circle of a basketball court. Every scientific writer always compares everything to the atomic bomb dropped on Hiroshima, so let's state this right away. Lightning will deliver energy equivalent to 2 atomic bombs into the air and onto the ground. From a practical standpoint, this is enough to power a gaming console and television for millions of years. In other words, it would satisfy the electricity consumption of the USA for 5 minutes. The discharge will be as narrow as the central circle of a basketball court, but will leave a crater the size of the entire court. Inside the channel, air will turn into high-energy plasma, and the light and heat from the discharge will spontaneously ignite surfaces within a radius of several miles. The shockwave will level trees and destroy buildings. In general, the comparison to Hiroshima is quite appropriate. One could hope to collect energy from the discharge using a lightning rod. The mechanism of how lightning rods work is debatable. It is traditionally believed that they create a channel for directing current straight into the ground, although some argue that they actually repel lightning by constantly transferring charge from the ground to the air, reducing the voltage difference between the cloud and the ground, and decreasing the likelihood of a strike. In any case, the lightning rod won't protect you from Trevor's lightning. A copper cable 1 meter in diameter could theoretically conduct a brief surge of current from the discharge without melting, but unfortunately, what is at the other end of this cable probably won't conduct electricity as well, and the explosion will scatter everything nearby. Nevertheless, it is obviously impossible to gather all the lightning in the world in one place. But what if we try to collect lightning from one specific area? There is no place on Earth with constant lightning discharges, but there is a region in Venezuela that fits this description. In the southwestern part of Lake Maracaibo, a strange phenomenon occurs: constant thunderstorms. There are 2 areas, one over the lake and one to the west, where storms form almost every night. These storms can generate a lightning flash every 2 seconds, making Lake Maracaibo the lightning capital of the world. If you somehow manage to collect all the lightning strikes from a single night of the Catatumbo storm through a lightning rod and use it to charge a massive capacitor, it could store enough energy to power a gaming console and television for about 100 years. If this were to happen, we would probably have to revise the old proverb to something like, lightning always strikes in the same place. That place in Venezuela. Better not to stand there.